it's a group project, but I mean,
What's up, geometry
it's not a
students?
project.
Let's talk about the lesson. We are taking regions, we're spinning it, they're creating three-dimensional objects. If you can't see the objects, I found a cool program that I'm going to use to show you what the objects look like when you spin them. But the goal is for you to create the visualization yourself. You need to start by able to find to know what the region R is. So we want region R, which is y equals 3. Y equals 3 passes through the line y equals 3. X equals 1 passes through the x coordinate of 1. X equals 6. X equals 6. X axis.
Yeah, I'm thinking. Yeah, yeah, but I wasn't one vote. He wasn't one vote. And I know it's a group project and it's graded as a group grade, but it's not a group project if I have to do everything. You know.
Cool. So we got to find the perimeter, we got to find the area, we got to figure out what the shape's going to look like when we spin it.
That was the
So that's what
I was writing.
All right. So we got the region, it's got an area, it's got a perimeter. It's not really important. What's important are the lengths, like this length being 1, 2, 3. This length being 1, 2, 3, 4, 5, right? 6 minus 1, 5. Making sure you understand those lengths. Then, sure, the perimeter is 16. Sure, the area is 15. This is in units to the first power. Area is in units squared. But now, what if we spin it? Hopefully you can see, if you take that region and spin it, this is what it's going to look like. That. Now, you might not be able to tell, but you got to be able to tell. When you spin it, it creates a cylinder. The cylinder has circles on the right and the left. When I spin this region vertically or horizontally over this y equals 0, so it's over the y equals 0, but it ends up being spun this way. We have circles on the right, left. We have a height, this length, circles on the right and left. That's the most important part. Where are the circles? Because I'm spinning it. It's on the right and the left. So here is what happens. It creates the cylinder that it's on its side. Where this is 5 and this is 3. You might be able to see it here if you want.
So
See that 3 is the radius. You can see 5 is the height. Okay. So what is the shape? It's a cylinder. What is the volume? Pi r squared h. This is the radius. This is the height. Now, what you might have to pay attention to is what would happen if we revolve it around a different line, which we'll do for other regions. Surface area, I have 2 circles. And I have the rectangle, which is rolled out to be this circumference times this height, so 30 pi. So I have 918 plus 30 pi is 48 pi. Now the question is, could you see what would happen if you revolve it around the x equals 0 line, the x-axis? That's important. What happens if we revolve it around x equals 0, which is the y-axis? Well, hopefully you can see that you're going to be rotating around this way. Now, if you rotate it around this way, really, it's like this. You can see that's horrible. It's like, it ends up creating this rectangle on the other side, we end up creating circles on the top and the bottom. But since there is space in between the y-axis and the region, we create this hole. We create this outer side and then this outer cylinder with a circle on the top and on the bottom. And then we create an inner cylinder with a circle on the top and the bottom that ends up being a hole. Stuff like that that we need to think about. Like this gets revolved around that way. It's not asked of you here, so you don't have to do it. All right, next region, x-axis. Here's the x-axis. X equals 6. Equals 1/2 x. Easy. X-axis is when y is 0. When y is 0, x has to be 0. You have the point 0, 0. If x is 6, y is going to be 3. So at this point, 6, 3. It helps to understand the dimensions. This is 6. This is 3. This is going to be 36 plus 9 rooted, which is root 45. Perimeter is 9 plus 3 root 5. Area is half the base times the height. So a triangle, obviously. This around the x-axis, what would it look like? Okay, think about it, spun around the x-axis. Think about what it would look like. Let's see, do you get this? Spin this region. Here's the region right here. Here's the region. Spin this around the x-axis and it creates a cone. What is key about the cone? The circle is on the right side. This is the height. There's the circle on the right side. So cool. Cone. 1/3 area of the base times the height. Area of the base is 9 pi. Height is 6. So it's 3 times 6, 18 pi. Surface area is 9 pi plus a pi RL. This is L. This is the R. This is the H of the cone. You know why it's pi RL? Pi LR is what I like. It's because it's talked about this before. We have this net when we unroll this middle part. This middle part turns into this. This is L. When we unroll the middle part, this is the circle's circumference. So this is 2 pi R. We don't have H at all in this. It's just this L and this 2 pi R. Well, if we looked at the entire circle, whose radius is L, the area is pi L squared, the circumference is 2 pi L. Well, why is it pi LR? Because it's pi L squared, and then I need the 2 pi R portion of the 2 pi L. Well, the 2 pi's go away. One of the L's goes away. It's always pi slant height R, pi LR. Cool. Y-axis. That's the x-axis. Y-axis. Y equals 1. Y equals 3. X equals 4.
Okay. Thank you.
Yeah, does that answer your question?
Yeah,
Okay, so we can do both into those.
yeah, most of it.
Yeah, also. Okay.
So it's been late, it's not like. Okay,
Yeah, Ramsey, I should be advisor.
thank you.
You can select them as that you could like meet it so that talk to me.
Okay, thank you.
See you.
Okay, so that's the shaded boxes, 8 units squared, the perimeter's 8. What if we rotate this around the y-axis? Okay, taking the region, spinning it around the y-axis. If I spin around the y-axis, I create circles on the top and the bottom. So we got y equals 3, y equals 1. Hopefully you can see this. You won't have this to help you. This is just for demonstration purposes. Y equals 3, y equals 1. From 0 to 4. Spin this around. X equals 0. Here's the region. Spun around x equals 0. Creates this cylinder. This cylinder doesn't have circles on the right and left. The cylinder's got circles on the top and the bottom. Okay, because like the region is spun all the way around this way, creating a circle at the top and the bottom. This height stays the same. Okay, so there you go. There you can see it. If you need help seeing it, you come in and we'll like just practice what shape is created. So we can kind of see it here. If we throw this over onto that side, and if we want to kind of create a circle here, but most of you kind of understand that it's a regular cylinder, not like a wheel, but more like a cup going straight up and down versus a wheel with the circles, the cups, the circles are on the top and bottom, a wheel, the circles are on the right. This is still 4. This is the radius. This is 2. This is the height. Area of the base times the height, 32 pi. All right, what if we revolve this around the x-axis? Now, here's where it's tricky. Take this region, revolve it around the x-axis. If I spin this around the x-axis, this outer guy, okay, this I'm spinning around the x-axis. This outer guy goes all the way around to the outside. But this guy gets spun, creates this inner guy. What we end up having is this cylinder that has a hole in the middle. You can't see it. Try to imagine it. Or I can use this for you. Use your fingers. Think about the region. Think about a piece of paper going around, ends up being like a toilet paper roll. Okay. Thick walls, hole in the middle, toilet paper roll. I'm really writing that. Toilet paper. Circles on the right, circles on the left. Where we actually have two radiuses. We have this length, which is 4. And that becomes a radius that goes to the outside. And then we have this length here, which is 1, which is actually like a radius on the inside. Let me show you if you didn't see it. If I take this region and spin it around y equals 0. Okay, spin. You can see it creates this cylinder with a hole in the middle. You see how this region right here, this rectangle spun around the x-axis, creates this cylinder with the hole in the middle. Okay. This is still 4. It's 3. Y equals 3. All right. That's y equals 3. This is y equals 3. This is y equals 1, which creates 3 and 1. This is still 4. Okay. All right, so I have the volume of the outer cylinder minus the volume of the hole. We notice that it's got circles on the circles on the right and the left. Oh my God. Well, probably actually can't see it. What? So we have a 9 pi times 4. That's the big cylinder minus the hole, which is a 1 pi times 4. That's 36 minus 4, which is 32 pi. Pi r squared h, pi r squared h. Okay, rotate this around y equals 3. This is cool. Y equals 1, x equals 4, y equals 3. This region revolved around y equals 3. Where's y equals 3? It's right here. What happens if I spin it around y equals 3? Well, if it gets spun around here, it's just going to reflect itself over here, creating a normal cylinder with circles on the right and left. Let's see that. Come back here. Spin this around y equals 3. And ends up rotating itself just right over this line. We can see it creates a normal cylinder. It's a wheel because these circles are on the right and the left, but there's no space, there's no negative space, there's no hole. So this length, which was 2, is the radius again. This length, which is 4, is the height again. Circles are on the right and the left. Right. Y equals 2x y-axis. Here's the y-axis. Y equals 4. Now, I've done this so many times that I'm like good at it. If you don't know how to create the region, that's something you can work on. Well, y-axis is when x is 0. So what are the points on this line that we'll need? We'll need the intersections. If x is 0, y is 0, you have the point 0, 0. If y is 4, x is 2. Okay. Here's the region Q. It's a triangular region. This length is 2. This length is 4. This length is root 20, which is 2 root 5. The perimeter is 6 plus 2 root 5. The area is 4. If I rotate this around the y-axis, I spin it around the y-axis, the circle is created on the top. It becomes a cone with a circle on the top. Y equals 2x, y equals 4. X equals 0, x equals 2. There it is. This region spun around the y-axis creates this cone. This cone has got a circle on the top. So this x distance is the radius of the circle. So this is 2, this is 4. Ooh, surface area, cool. So I got a circle, then I have a pi RL, pi LR, L, this is R, this is H, this is L, when this turns into a cone. So pi times 2 root 5 times 2, which is 4 root 5. Y is a pi LR. Again, I'm going to show you one last time. This is L, and this is coming from the cone. This is the circumference of the circle that creates the cone on the bottom. This entire circle has an area of pi L squared, but the portion of the circle I have is a 2 pi R out of a 2 pi L. The L's cancel, the 2 pi's cancel. What if I revolve this region around the x-axis? So here's the last one. Again, this is 2, this is 4. I don't know what it is. This is 4 root 5. All this around the x-axis, what happens? Well, you can see the circles are going to be kind of on the left and the right side. We kind of make this wheel type object. And what you should be able to see is that we have a cone missing from a cylinder. You can't really see it. I'll show it to you. I take this region and revolve it around the line y equals 0. And I spin this region. I can see circles are on the right and the left. Boom, circles on the right and left. But I have this missing cone in the middle. We end up having like 2/3 of the cylinder because we subtract a third. So it's a cylinder with a cone missing. Got a cone. That's the radius because the circles are on the right and left. That's the height. This is the slant height if I need the surface area. But I don't. We have the volume of the cylinder, which is pi r squared h, minus the volume of the cone, which is just 1/3 pi r squared h. So it ends up being 2/3 pi r squared h, but let's just do it out. This is 32 pi, and this is 32/3 pi. This is like 32/64. 96 pi thirds minus 32 pi thirds is 64 pi thirds. Okay. If you don't get this, you just copy this down. Well, we have a test on Friday. It's up to you guys whether you want to do the extra work to figure it out. Okay. You got your big quiz review as extra practice. Okay. Peace.